So let's look at number 1 real quick. And I want to highlight what's going on here. Where do planes ABFE, ABFE, we're talking about this side of this triangular prism. We want to know where this yellow side intersects with plane ACDE. 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 We're talking about this pink side. And so if I think about where the pink side, the left side of the triangular prism, where does it touch the yellow side? It touches, not just in one spot, it touches along all of these spots. Not just here, but it touches all the way down. And because it says it's a plane, planes extend forever and ever and ever. And this picture doesn't show it because it's showing the flat surface. But remember, a plane by definition means it goes forever. So that means that it must touch in a line. Two planes always intersect in a line. You have to have the double arrows on top. Otherwise, you would get it incorrect. Line AE is where these two intersect, or line EA. The second question is, where do planes CBFD and CBFD, so let me use the pin for that one, CBFD. The bottom, and FEAB, FEAB is the yellow one, so I'm going to put the yellow thing around this one. Where do the blue one and the yellow one intersect? They intersect this whole side right here. They touch in every single spot. There's an infinite places, so we're going to use an infinite line that has to have double arrows on top, either line FB or line BF. Any questions about number 1? Number 2. Write all the ways to name line AC. Here's line AC, and it's a line because it has double arrows. So you could say line CA. You could also say, so I have AC, line CA. I could say line DC, line CD. Those are my other two options. And even line AD and line DA. Those are all the same line. It would be different if I was talking about a segment, but because they're a line, because it goes forever and ever and ever, I can name it any of these other 5 ways. AC, CA, AD, DA, and DC and CD. We would say line because it has the double arrows. Any questions on 2? Number 3 says, what is the length of segment AXZ? What is the length of segment XZ? By the way, if it ever says something like this, XZ, and it doesn't have anything on top, that means the same thing. What is the length of? Traditionally, it's written like this without the bar. And so, how long is XZ? How long is it from -8 to 2? It is 10 units long, and you can actually just add them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can count. Or you can go, what is this distance, which is 8 units, plus the 2. 8 plus 2 is 10. Don't forget, distance is always positive, meaning it doesn't matter that this is on the negative side. This is a positive distance. There's no such thing as running backwards a mile and not being tired. You will get tired because you went a positive distance, even though you went backwards. Number 4. There are a couple different ways to solve it. I solved it the hard way, and then I realized there was an easier way to do it. The hard way was like this. Since B is the midpoint, I underlined that word. If this is the midpoint, then what that means is exactly in the middle. That means if I fold it, this AB is going to be the same as DB. These two sides are congruent, which means this 5x minus 1 is the same as this 4x plus 6. They are equal to each other. So what I could do is I could set them equal to each other, or The complicated way that I did it was I said this piece plus this piece was going to equal 68. I did this piece plus this piece equals the 68 because that's what DA was. You could have also just set them equal to each other. And the easiest way to do it, which is the way I figured out later on, well, if this whole thing is 68, then half of it is 34, and that has to be 34. I just divided it by 2. So I came up with multiple ways to solve it. You can do it any which way as long as it makes sense to you. In this unit, you will always have to make a decision. Are these equal to each other? Do they add up to be something? These add up to be this. This piece plus this piece equals the whole piece. That's called the segment addition postulate. We're also using the definition of a midpoint. Or we can set these two things equal to each other. Figure that out as well. Plug it back in. Either way, BA, the correct answer is 34. If you're working out the problem, you're going to get that X is 7. That's not what it asked for. Always look to see what it's asking for. That's what the A students do. The C students will stop when they figure out what X is. Keep going. Number 5. When I look at number 5, it says, what is the measure? That's what the little m stands for. What is the measure of angle CAD? So CAD, I'm going to highlight it. Looks like this. And we're only talking about this angle right here. And you would never use a protractor this way. You're supposed to put the protractor at 0 on one of the sides, and they did not do that here. What they have is they have CAD, and it goes here from 25 degrees over to 90 degrees, or from 155 to 90 degrees. So what I would do if I were you is I would just do some subtraction. I would take this number, whatever that number is, 90, and I would subtract 25 from it, like I did there, to figure out how far it is. And if you're lazy and you just want to count, you can go 10 degrees, 20, 30, 40, 50, 60, and 65 degrees is how big the angle is. You could count that way as well. Why this is tricky is because this side is not on 0. So if you want, you can do the 90 degrees minus the 25 degrees, and that makes sense as well. Turning the page. Going to the top. What are two names for angle 1? So we're talking about this angle right here, angle 1. And what I'm hoping you remember is that we always name it side, vertex, side with the angle symbol. Have to have an angle symbol, and so you can either say angle KUT or angle TUK, and it has to be that way. What you cannot do is you cannot just say letter U, because we don't know if we're talking about this angle U or this angle U or the whole angle U. Perfect, just set it right there. And so we have to be that these are the only two answers we could have. Any questions about 6? Number 7. Angle JKL and angle LKM are supplementary. What that means is this angle plus this angle are equal to, supplementary means adds to 180 degrees. That's what that word means. This plus this equals 180. So that means JKL, this 3x plus 8 plus the 5x plus 4 should equal 180. That's where this equation comes from, right here. They're supplementary. They add to 180. Then what do? I combine like terms. 3x plus 5x is 8x. The plus 8 to plus 4 means they add to 12. You don't change the signs when they're on the same side, the equal sign. And then what you do is you subtract 12, because now you're going to the opposite side of the equal sign. 180 minus 12 is 168. And you divide by 8. You can use a calculator for that. It comes out that x is 21. Is that what I asked for? Let's see, x is 21. No, What is the measure of LKM? LKM is 5x plus 4. So now that you know what x is, you have to take it, plug it back in to get what the correct answer is. The number one most missed question on the multiple choice will have x equals 21 as one of the possibilities. But the question on the multiple choice is going to say something along the lines of what's the measure of this angle. So you have to make sure you don't just figure out what x is, that you plug it back in order to figure out what that angle is every single time. Okay? That's my biggest hint to you on this test. It's just a multiple choice question. Any questions on 7? Number 8. Ray XF bisects. There's a key word. Bisects means cuts into 2 equal pieces. So if I cut into 2 equal pieces this angle, then the measure of angle EXF is 34 degrees, and this cuts it into 2 equal pieces. Then that means if this is 34, then this angle has to be 34. That's what the word bisects means. It means cuts into 2 equal pieces. Bi meaning 2, sect meaning it's being cut into 2 equal pieces. 34, 34. And then the final answer or question says, what is EXG, meaning side, vertex, side. EXG, what is the whole angle equal to? 34 and 34 is 68. Let me highlight that real quick. EXG is E, then X, then G. We're trying to find this whole angle. So you have to put them together in that case. Number 9. What angles are vertical angles? Vertical angles are the ones that are across from each other. They're the ones that are opposite V's. And I know vertical angles as like this kind of angle, where this angle is across from that one, and the doubles are across from the other doubles. That's how we wrote it down. So when I'm looking for doubles, 2 and 3, nope, those aren't vertical. 2 and 4, nope, because they're not the same size. The only pairs that are vertical angles are 1 and 3. They're across from each other with 2 lines. Look at this line. Look at this line. The ones that are across from each other are equal to each other. You could also say 3 and 1. I would also accept that. It's the same thing. Number 10. What is the other endpoint of a segment with a midpoint of -6 and an endpoint of -13? So what it's asking is if it has an endpoint of -13, I put an endpoint right here. Here's -13. And it has a midpoint of -6. Here's the midpoint. That means it's halfway at -6. I have to figure out how far is it from this endpoint to that midpoint. How far is it from -13 to -6 on the number line? If you don't know, you could count. -12, -11, -10, -9, -8, -7, -6. How many is that? 1, 2, 3, 4, 5, 6. It's 7 units long. And then what? If that's the midpoint, where is the other endpoint? So we have to go 7 more units this way. Well, if I'm at -6, 1, 2, 3, 4, 5, 6, that's 0. And 7 units would be at +1. That's my correct answer. Visually, you could write out a number line if you wanted to. Or you can just do some subtraction and know that that distance is a positive distance every single time. You could think of it as absolute value, but that just might make it a little bit more complicated. Keep it simple. No questions yet? Number 11. Point X does not lie on line AC. Point X does not. Can point X lie on the same plane as line AC? My answer was yes. Here's a picture that proves it. Perfect, thank you. Here's line AC. Here's point X that is not on line AC, and it's still in the same plane, and we draw planes by drawing this parallelogram around everything. It means it's nice on that nice flat sheet of paper. There's my answer. And by the way, your line could be in any direction as long as X is not on the line. So your answers vary on this. Number 12. Find the midpoint of XY if X is negative 7, 11 and Y is 15, 7. How do we find it? We find the average of your X's. You add your X coordinates together and divide by 2. Negative 7 plus 15 divided by 2 comes out to be 8 divided by 2, which is 4. And then we do the same thing with our Y coordinates. Think of this as your first X, and this is your second X. Think of this as your first Y, and this as your second Y. What we're using is the formula x1 plus x2 divided by 2, y1 plus y2 divided by 2. We're using this formula to get our results. We're averaging our X's. Now we're going to average our Y's. 11 plus 7 is 18. Divided by 2 is 9. Any questions on 12? Going to 13. 13 says, what is the distance between this point and this point to the nearest tenth? That tells you round to 1 decimal place. If you don't know the formula, I'm going to have it for you on the board. It will be what's your difference between your X's plus what's your difference between your Y's squared, added together, and you take the square root. That's our formula right here. So what we do is we take this X and we subtract that negative 3. The hard part for a lot of you, when you subtract a negative 3, you are actually doing the opposite of subtraction. You are adding the opposite. Don't forget to change those signs when you plug it into your calculator. And when you subtract your Y's, 5 minus a negative 2, you're doing the opposite of subtracting. You turn those into positives. Let your calculator do the work. Use parentheses with your calculators, and it makes everything easier rounding to the nearest tenth. In my class, what I've been trying to show you is how to punch the whole thing in. Oops, wrong button. To punch the whole thing in with the square root, with the parentheses, the negative buttons. So see how I have the negative 5 plus 3 in parentheses squared? You're going to need to punch that in. Then put the plus sign. Then more parentheses. 5 plus 2 squared. Press the equals button and switch it to a decimal to the nearest tenth place. This rounds up. Okay? Any questions about that? Almost done. Use the following illustration. What is another name for plane LTV? Let me highlight that real quick. Here's L, here's T, here's V. Think about this plane. What's another name for it? In order to name a plane, you have to have 3 points. So if I want the same 3 points that are on that plane, I could add this extra point X, LXV. I could say VLX. I could switch up those letters. I could also name it by just the capital letter that's in the corner of the rectangle or the quadrilateral, whatever, the parallelogram. That's what that's called. Those answers will vary. As long as you do not use this point S, you are okay with those ones. And Z is not a point. Z is the name of that plane. Question, Tim.
You can't name it T because it's bisecting with V.
Say it again.
You can't do the vertex because it's bisecting with the S. You can't just
You would not just be able to label this plane T, because T is not the name of the plane. You need 3 points that are non-collinear. Okay? Ray?
So would VTL be the answer?
VTL, yes, that's the same thing. Well, here's the only thing. This VTL and LTV, all you've done is you've used a different order. It's the same thing.
But it is the same thing as
True. You're absolutely correct. If they worded the question for you to use other points, what's another way to name it? I might pick a different point. And be ready for this to be on a multiple choice question, so be flexible. Okay? Where would plane STX intersect plane Z? So plane Z is this nice big pink one. Let me just highlight. Here's plane Z. I'm going to put that around plane Z right there. And plane STX. I want you to think of plane STX as this vertical plane that is slicing into this piece of paper. Think of it as a piece of paper slicing into another piece of paper. Where does the plane intersect a plane? Planes intersect each other in a line, so you need to find the line where it touches. And I can already see it's got to be right here where they touch. And I would pick the 2 closest points. Here are the 2 closest points, XT or TX, and it has to have the line arrows on top. And you can name that in any of those ways, but I would pick the 2 that are the closest ones where it's touching. Questions about B? Part C, 2 opposite rays. The opposite rays are rays that point away from each other and they form a line. They have to have the same end point. I told you in my class to make sure that you know that that is called the start point. You could think of it like that. Starts at T, goes through L, starts at T, goes through X. So when you write it, you write the start point. Not really called the start point. Every textbook will call it an end point first. TL, ray TX, and it has a ray bar on top. 1 arrow going away. These are rays. But they don't point opposite of each other. They do in the picture. We have to write it down. End point first. And then it goes forever through L. This will let you know which direction it is. End point first. It goes forever through X. They go in opposite in the picture, not necessarily how we write it down. 15. They tell you DEM is 122 degrees. D, then E, then M. That means this whole angle is 122. Let me just highlight that real quick. That's the first thing I know. And then they tell you that this one is 6y minus 3 and this one's 3y minus 1. So these 2 things added together equals 122. There's my equation. When I add these 2 things together, I get 9y, get minus 4 equals 122. I can add the 4, I can divide by 9, and I can get what y is equal. But I don't stop there. Never stop when you figure out what y is equal to. Look at what they're asking for. D-E-K. D-E-K. They're looking for this yellow one. D, then E, then K. They're looking for this yellow one. So we have to plug that 14 back in here to figure out what DEK is. 6 times 14 is 84 minus 3, which is 81 degrees for my answer. Any questions? The last page on the review is something that you will see similar on your test. There's a whole section on it. And this goes with those flashcards that we did for my other classes. where we had to know what an acute angle was. The acute angle picture is an angle that is less than 90 degrees. Let's look for the picture that's an acute angle. See how this angle is smaller than a right angle? There's my picture. And it goes with statement O, because O is between 0 degrees and 90 degrees is an acute angle. It's smaller than 90 but bigger than 0. What does angle addition look like? It's the H picture. It goes along with statement J. So let's look at those two things. This angle plus this angle equals the whole angle. That's what the angle addition postulate says. This matches with what J says right there. The measure of angle AXB plus the measure of angle BXC will equal the total measure of angle AXC. The angle addition postulate says this angle plus this angle equals the whole angle when they are next to each other. What about midpoint of a segment? Midpoint of a segment is F and M. So B is in the exact middle. It creates two congruent pieces. B is the midpoint of AC. This one goes with that one. What about an obtuse angle? It looks like B, and it goes with something that is between 90 degrees and 180. It's bigger than 90 but smaller than 180. What's a right angle? It goes with this picture, which is A, and it goes with the definition, which is 90 degrees. The segment addition postulate is E, because what it says is this piece, this segment plus this segment equals the whole segment, which matches right here. Segment AB plus segment BC is equal to segment AC. The length of AB plus the length of BC equals the length of AC as long as they're collinear. This is the segment addition postulate. Running out of room. Let me scoot up just a bit more. Segment bisector is G and L. If something cuts through the midpoint, that's called the segment bisector, and it looks like this. It could be a line, it could be a plane, it could be a ray, but a segment bisector is anything that cuts through the midpoint of a segment. Doesn't have to be a line. It can be a ray, it can be a plane as well. And the last one, supplementary angles, are angles that add up to 180 degrees. Usually they are adjacent to each other, so that's why we have D and then the letter I for the statement. You see how you had to pick a picture and a statement that goes with it? That's what your test is going to look like. Any questions?